This conference will now be recorded.
Hi everyone, welcome to Isha Training Solutions. So we will wait for 2 more minutes for other learners to join, and then we will start our discussion. So we'll wait for 2 more minutes, and then we'll start our discussion, guys. Thank you. Yeah, once again, welcome everyone. Welcome to Isha Training Solutions. So in yesterday's topic, yesterday's session, what we did, we were discussing about the course content. Okay, what we are going to learn basically with respect to performance engineering topic. That is what we discussed yesterday. Okay, today what we are going to do, we are pretty much going to start and understand performance engineering introduction part of it. Okay, so introduction to performance engineering. Okay, performance engineering. Okay, so whenever we are talking about performance engineering, first of all, what we are going to engineer things, fine tune things, optimize things. Okay, engineer means you are going to do optimization, fine tuning. All those things are actually involved, right? So that's where usually people will have a little discussion like what is actually performance testing means and what is actually performance engineering means. What is actually performance testing means and what is actually performance engineering means. So performance testers mostly what they are doing, they are only doing the testing activity. What is there? Say like based on the NFR that are available, they are going to prepare the script, they are going to execute it, and they are going to provide the number. Say like they'll say login transaction took 5 seconds, search transaction took 12 seconds, logout transaction took 3 seconds, like that. They are going to only provide numbers in the case of performance testing. Usually if you look at it, the outcome of the performance testing is actually the report. In that report, mostly where it is actually focused on, the focus area is actually average response time. So in that case, what data is actually available? Login details, search detail, logout details, like the transaction level response time data that are available. So basically, in testing side, what you are doing, you are focusing on numbers. Whatever the outcome that you are getting it in the performance testing, that numbers you are focusing on. That numbers you are focusing on. That is one thing. So testing means you are only testing the application. Engineering means what you are actually doing. Say like somebody is actually saying like 12 seconds as a response time for search transaction. So what performance engineer will do, they will analyze, understand, and try to optimize that if it is actually having high value. What they are doing, they will analyze, understand, and then try to optimize the value if the value is actually high. Okay. because it may be a UI level, it may be application level, or it may be database level, or it may be infra level. It may be infra level. Who knows? It actually categorized into different things, right? So as a performance engineer, what you are doing, when the performance testers they are saying the numbers, means performance engineers will think about reason for the numbers, reason for the numbers, and they are going to work on identifying the problem, fix the problem, optimize your application performance. That's where performance engineering is actually applying your knowledge, and then you are trying to understand what is actually the problem, optimizing your application performance. There performance engineer role is actually coming. The process of doing this actually called as performance engineering. Okay, performance engineering. Okay, so what is that meaning? So in that case, your focus area is actually across. Your focus area is actually across. Okay, so what you are going to do, you are going to understand. Okay, I have a problem statement. I am going to analyze it, and I am going to provide the solution for that. I'm going to provide the solution for that. That is what a performance engineer basically they are going to do. Basically they are going to do. Okay, I'll take a pause here. Any question, guys? Still no? Anybody have any question? So performance engineer means now we have a basic understanding. Performance tester's role is different. Performance engineer's role is actually different. Okay, it can be two ways, right? Proactive, reactive. What is proactive? What is reactive? Proactive in the sense like in certain matured organization, what they are doing, they will have a person called performance engineer. During the early stage of the application development itself, they will be part of each and every meeting, because their objective is to what, their objective is to find the problem statement and then resolve the problem in the early stage itself. That is one way. The other way is reactive. What is that reactive? Say like the application is there in the industry for 5 years, 10 years. Now what customer they are feeling is that like application is actually heavyweight, application is actually slow, application is not reacting properly. In that case, what you can do, you can do the performance engineering again. So that time also performance engineer will involve in those optimization as well. Okay, so that is the other way, either a proactive way or the reactive way, but mostly it is actually reactive only. Okay, during the early stage having the performance engineer in your organization is very less, but where there is a problem and then inviting the performance engineer to fine tune the application performance, that is what in industry right now everybody is actually doing. Everybody is actually trying to do this one only. So now we have a basic understanding of what performance testing means, testing the application. Performance engineering means optimizing the application, fine tuning the application. Layer by layer you are trying to resolve the issue. Okay, so you are the performance engineer will take the ownership to understand where the problem, how the problem can be resolved, so that your application performance will be very good. That is what performance engineers they are going to do. I'll take a pause here, guys. Any question till now? Yeah, so what is our next topic? Next topic is actually the important one, performance engineering life cycle. Performance engineering life cycle. So this is what I told you yesterday also. Any activity that you are doing, there is a life cycle. Okay. SDLC, PTLC, STLC, like that. This is actually development life cycle. And this is actually performance testing life cycle. And this is actually software testing life cycle. Software testing life cycle. So every activity that you are doing, yes, there is a life cycle involved. Okay. So even performance engineering life cycle is actually PELC. So this is actually the performance performance engineering performance engineering life cycle. So in performance engineering life cycle, what are all the individual layers that are there and what are all the activities that are carried out in those life cycle? So what will I do for the understanding purpose? I will compare the SDLC and then the PELC. For the understanding purpose, what will I do? I will compare the SDLC and the PELC. Okay. So the first point is requirement gathering. Requirement gathering. So requirement gathering when the developer is actually doing. So this is actually SDLC first layer. SDLC first layer is actually your requirement gathering means what your PLC performance engineer what they are doing. They are also analyzing your requirement and then system sizing related things they are working on system sizing related things. Okay, so this is on the PELC, performance engineering life cycle also. They are also analyzing the requirement and they are also planning to do some kind of a system sizing. System sizing. So, what are all the things usually they will think about during this time period? They'll think about growth rate. Growth rate. Okay, how much of a growth rate is there over the period of time? Over the period of time, what is the growth rate? This year is so and so, next year is so and so. What is actually the growth rate of the application? Because of the growth rate of the application, is there any requirement that has to be changed? Is there any provision that is there in your application, so that in future if you are getting too much of a traffic, whether the application is actually having the capability to withstand it or what, all those things you have to discuss during the early stage itself. During the early stage itself. Okay. So that is actually the growth rate. Okay, that is actually the growth rate. Even you have to think about the storage requirement. Storage requirements. I mean, how much of a storage that is actually needed for your application over the period of time. If your storage is actually going to increase or what, because of the growth increases, storage will also increase, right? The amount of data that we are storing is also increasing, right? So which means that we have to think about storage requirement also. We have to think about storage requirement also. Okay. And then we have to think about end user response time, or you call that as response time also. Response time related things also we have to think about, or even the user, even you call that as total user or concurrent user, whatever. Total users or concurrent users. Okay, that also we have. Even we have to think about the peak transactions or or individual transactions, or what is your right resource to provide satisfactory performance. Okay, right resource to provide satisfactory performance. Okay, that also you are going to discuss in the early stage itself. Okay, so these are something that performance engineers will think about. Okay, actually saying this has to be done by everybody, but mostly people are result oriented, right? People always think about when to complete, what to complete, how to complete, how many we can complete. That is what people will always think about. Actually saying they have to think about these things also when they are doing the requirement gathering discussion. But if they are failing to do so, no problem, performance engineers can cover that up. So how to cover that up? Yes, they can understand growth rate related, storage related, response time related, concurrent user related, peak transaction related, and then the resource related. All those things they can focus on, because these are very very important. If there is any deviation in these things in later part of the application development or maintenance, you are going to face a serious problem if you are not properly having the provision. That is the reason we are saying we need to have an understanding of all these things in the early stage itself. Okay, so I'll take a pause here. Any question guys still now?
Yeah, hi. Tarun this side.
Hi Tarun.
Yeah, hi. So in the PTLC, when we mention about the requirements, there are majorly there are non-functional requirements. So what I could see here is, so when we mention that the same requirements gathering in the PELC, it is related to the functional, non-functional, and the application and the architecture level. Am I right?
See, PELC, end of the day, whatever you are having, end of the day it is also attributed to performance. Okay, so whatever the functionality that you are developing, whatever the language that you are using, whatever the technology that you are developing, everything, at the end of the day it's actually focusing on performance only. So that is the reason I attributed these metrics related to that. But if you still granularize these requirements, I mean, as per your point, if you wanted to granularize and say how many screens you are going to develop, how many page navigations that are there, or what technology that you are going to use, what are all the language that you are using, what server you are going to use, like that. If you wanted to granularize, yes, you can still do that in the requirement gathering stage itself. But end of the day, anything that you focus on, any activity that you are focused on, end of the day our focus area is performance. That's the reason
Yeah, yeah.
I mentioned the performance attributes.
Okay,
Okay,
so
I
even
mentioned the
though if
performance.
yeah, yeah, got it, got it. Even though if we ask about the server and the architecture level, it points out towards the performance.
Yeah, correct.
Yeah, yeah. Thank you.
Yeah, sure, thank you.
So Saravanan Neeraj, so every time these requirements is necessary, right? This checklist is same for all, or
Yeah, yeah,
is
these are the
different for
uh,
different.
no, no, these are the checklist always you are focused on. Because say if you are not focusing on the user level, response time level, all these things in the early stage, even the resource level or the growth rate level, all those things you are not focusing on the early stage, later part of the time, if there is any deviation in any of these metrics, you cannot roll back, because you already developed your application, or already decided what you are going to do. So once you are decided everything, and then you are trying to change something, sometimes the cost of redoing is actually heavy. So that's the reason in the early stage itself, maybe if I missed one or two points, but all the way these are templates. You need to focus on all these things, so that your cost of recovery will not going to hurt a lot. But if you are missing these things, the cost of recovery would be very very high. And in the later part of the time, say you cannot say, my growth rate is actually totally different, but your current configuration of the application is actually low. So in that case, Yes, configuration can be changed, but architecture cannot be changed. So in that case, you have to decide each and everything in the early part of the discussion itself, so that in the later part of the time, you don't want to redo certain things, or you don't want to invest a lot of money for recovery. That is the reason we are
Mm-hmm.
investing, or that is the reason we are focusing on all these things in the early part of the discussion itself. Clear?
Yes.
Yeah.
And the same checklist as related from the also development and for software testing also is SDLC and
No, no, no.
STLC.
For them, there will be a little difference, okay, because their
Mhm.
nature of work is actually a little different, right? But
Okay.
SDLC people, okay, what development people are doing, they'll collect the requirement, convert that into application. But
Yes.
PELC people, they are not actually result oriented people. I mean, yes, they are result oriented people, but they are not literally time bound people. For them, application has to work in a nice way, in a optimized way, in a fine tuned way. That is their
Mhm.
objective. Performance engineering people will think about that, but developers are not
Mhm.
like that, right? Developers objective is completely different. For them, get the requirement, convert it into screens, provide it to tester, provide it to UAT tester, deploy it into production. That's all. That is their life cycle. So for them, their focus area is little different. But for performance engineers, the focus area is little different. That is the reason I mentioned these points.
Okay. Okay. Understand. So,
Yes, sir. This is generally followed in the waterfall model. So, what about the agile model? How we can go ahead for that?
No, any place the requirement gathering will be there, right? Agile also, maybe the period of time would be little brief, but any activity that you are doing, there should be a requirement gathering phase. Everywhere you have to do it. It's not about waterfall or the agile. Wherever there is a requirement understanding place is there, you have to do all these things. Okay.
Okay. Yes, sir.
Yeah. Yeah, sure, thank you. So the next, I mean, requirement gathering is done, and on top of it, what everybody will do, even the developer, what they will do the architecture review, right? Architecture review. So that time, even your performance engineer should also do the architectural review. Why? Very, very important. Because you should know your design should be simple. Okay, you should have a simple design and implementation. Should have a simple design and implementation. Okay, because everybody should understand your architecture. Everybody should know where the data flowing from top to bottom, or your downstream system, upstream system, middleware, where the data, what data is actually going. That clarity should be there. You should not, I mean, you should not make your architecture so complex, and that is not needed also, right? Say an example. You wanted to take some data from a downstream system, means try to take as simple as possible. You don't make it complicated by going to multiple systems to take a single data, which is not even required. So you have to make your architecture in such a way that it is actually simple design and implementation. You should not touch your nose around your head, right? So you should not do complicated things for a simple activity. So which means that your architecture should be simple enough, so that you can easily understand, so that there is a complexity involved, you can easily understand it, how the navigation that is actually happening from one system to the other system, and how the data is actually traveling from one system to other system, like that you can easily understand it. Okay, so that's the reason I'm saying your architecture should be simple enough, and the navigation should be very, very easy to understand. Okay, and then you have to choose right algorithm, or you call that technical word as data structure, or you call that as framework, anything. Okay, so what you are doing, you are properly following the standards. Okay, the properly following the standards. Whenever you are doing, you are properly following the standards. And then first of all, you should know the limitation of your architecture. Limitation of your architecture, that is also very important. Okay, and document it. Okay, every organization, whenever they are doing the architectural creation or the design, they should initially know what are all their limitations actually. Okay, because because before even others are pointing out your problem, you should know what is your problem, and you should document it as well. Because in the future, somebody should not come and say, boss, this is actually a problem. You can say like, yes, I know the problem in the early stage itself, because we understand this is actually the accepted limitation. So which means that you should know the pros and cons of your application architectural limitation. Okay, because see, that's what I told you, your architecture is should have all the provision. Say like, today I'm developing an application. Okay, today I'm developing an application. After 3 years or 5 years, or later part of the time, I'm going to provide provision in my architecture to add one more application on top of my basic architecture. Okay, I need to add new application after 3 years or 4 years means, so what provision that I'm having in the current architecture, so that I can expand my application base into new application also. If I am not having any provision to add new application into my existing architecture, then that's a problem, right? That's a limitation. So which means that you should know the pros and cons of your application architecture, so that whatever the implementation that you are going to do, or if you are trying to do the implementation, whatever the limitation that you are having, that you should understand. That's where the performance engineer should involve in the early stage to understand the architecture, data flow, how it is actually happening, right from the top system to the bottom system, how the communication is actually happening. Why not this can be done in the other way also? Why it is actually the data is actually traveling to multiple systems? All those questions you have to get the clarity while you are going for the architectural review understanding. Okay, because say you talk about concept called scale up, scale up, or scale out. Okay, scale up or scale out. Okay, so scale up means you are scale up means, say like you are having a 4 GB RAM machine. Okay, you are having a 4 GB RAM machine. In that 4 GB RAM machine, there is a problem. There is some problem. You are trying to increase the configuration from 4 to 8, 8 to 12, 12 to 16, 16 to 32, 32 to 64, like that. If you are increasing in that single machine itself, you are trying to increase the configuration from 4 GB to 8 GB, 8 GB to 12 GB, 12 GB to 16 GB, 16 GB to 32 GB, like that. You are increasing. That is actually called a scale up. Scale up. Okay, that is also called as vertical scaling. Vertical scaling, you are increasing in a vertical way, that too into a single machine, okay. So that is actually the vertical scaling. Okay, just a minute. So this is what I told you, you are having a 4 GB machine, on top of it you are increasing the configuration. This is actually called as vertical scaling or scale up. Okay, so at certain point, say like in that single machine, at certain point you are unable to increase the configuration, because your motherboard is not supporting or your chipset is not supporting. So you cannot increase your configuration to a certain extent. Cannot increase your configuration to a certain extent. So in that case, what you can do, because that single machine is actually reached to the maximum configurational change. So in that case, what will you do? you are going to create similar kind of a machine, one more machine you are going to have it, and put it into a load balancer. You are going to create similar configuration of a machine and put it into a load balancer. Both the things you are going to put it into a load balancer. This is actually called as what? Scale out. Scale out. And otherwise called as what? Horizontal scaling. Horizontal scaling. Okay, scale up, vertical scaling, scale out, horizontal scaling. Okay, so during, whenever you are talking about these things and all, no, you can focus on those as well. You can focus on those as well. Okay, horizontal scaling means what, vertical scaling means what. Because in the cloud infrastructure nowadays, I mean, I don't know whether you guys are working in cloud infrastructure, but in cloud infrastructure these terms are very famous: scale up, scale out, horizontal scaling, vertical scaling, elasticity. All those things are actually very very famous terms and terminology. That is the reason I'm saying, because during the interview people will try to check whether you are able to understand the latest terms and terminology in the market. So that's the reason I'm saying about scale up, scale out, horizontal scaling and vertical scaling, all those things. But because your architecture should have the provision, your architecture should have the provision to do the scale up, scale out, or horizontal scaling or vertical scaling. If your system is not capable enough to do the horizontal scaling and vertical scaling, there is no point in discussing about all these things. But you should have that provision in the application. Then only you can spin up your machine horizontally or vertically, so that your application performance would be optimized. I'll take a pass here. Any question, guys? Till now, anybody have any question? Yeah. So the next activity after the code review, the next activity, developers will do coding. Developers will do coding or development, whatever you call that as. Okay, developers will do development. What performance engineers will do, they will do the code optimization. They'll do the code optimization. Why? Because actually this has to be done by the developer itself. Okay, they have to do it. Actually saying developer has to do all these optimization things and all. But in certain organization, I mean certain mature organization, the developers are actually taking this as a very serious work and they are really doing it. Actually saying they are doing it. What they will do, they say like in a team, some two seniors are there, three freshers are there, means what they will do, the junior people will develop the code. At the end of the day, they will share the code to the senior. The senior person will review the code and then they'll do the check in check out process and all. That is happening in certain mature organization. Actually saying, in certain mature organization they are doing all these things. But in most of the organization, what is actually happening, this code optimization is not done by the developer at all. Why? Because they have a timeline pressure, they have something to do, they are something to submit to the release team, they have to share the information to the production support team, like that. Lot of work that are there with the developer, so they are not focusing on these aspects. They are not focusing on optimization aspects and all. That is the reason nowadays it is actually taken by whom? It is actually taken by the performance engineer. Because performance engineer task is what? Checking the application performance and optimizing the application performance. That is the role of the performance engineer. That is the role of the performance engineer. So when the developers, they are keenly focused on development. Why? Because their objective is develop it, submit it, that's all. Whether it is actually performance wise good or what, that and all they are not going to think, because they are running behind timeline. Developers are running behind timelines, because of that they are not focusing on all these things. But performance engineers will focus on all these things, because their expectation is application optimization. So in that case, they will do it in a right way only. I'll take a pass here. Any question, guys, still now?
So, hi, Tarun again. So,
Yeah, sir.
to analyze the code and to optimize it, like from our end, then I think probably we should have that coding knowledge and all, right?
No, Tarun, that is what I'm about to say. Say, performance engineers contribution can be anywhere. Okay, it can be app side, it can be DB side, it can be infra side, anyway. Okay, and but I would say over the period, okay, not today or not tomorrow,
Yeah,
over the period, you should also end up in reaching to that place only. But right now, it is not bare minimum to start your performance engineering activity. Okay,
got it,
say
got it.
right now maybe you can contribute it in the infrastructure side, or you can contribute it in the performance testing side with additional data gathering side, or infrastructure side, database side, anywhere. Okay, UI side, anywhere you can contribute it. But even app side also you can contribute it. But what you can do, you can tell the problem alone. You can say there is a heap problem, there is a thread problem, there is a garbage collection problem, like that you can tell the problem. Once you are actually equip yourself to go to that level, and you are becoming good in doing that coding and scripting and everything, yes, you can contribute in the other way. How you are going to do, you are going to write your script, and then you are going to optimize the application performance. Okay, that is a long journey. But
Yeah, yeah,
your focus area can be anywhere, right? You can contribute it in the infra side, DB side, UI side, wherever you can contribute it. But the journey is actually moving towards becoming the full stack performance engineer, becoming complete performance engineer by contributing to every layer. That is the end goal. But right now, wherever you are possible to contribute, you can still do it, Tarun. Okay.
yeah, yeah, got it. Thank you.
Yeah, sure. So for the learners who joined today for evaluating us, okay, this is Kumar sir number 8019952427. Okay, so I'm pasting his number in the chat. You guys can take it. Okay, Kumar sir number I pasted in the chat. You can discuss about course timing, course content, fees related, anything you want to discuss. You can discuss with Kumar sir. And this is actually a weekday session, Monday to Friday, Saturday, Sunday holiday, and 9 p.m. to 10 p.m. IST, Indian time. Indian time 9 p.m. to 10 p.m. we are going to have the session. Correspondingly, in other locations, for the timing related information, I'm copy pasting this link in the chat. You guys can take it, because in that timing information is also there. You can check that out. US, UK, all those timings that are there, you can check it out. So it's a weekday session, Monday to Friday, 9 p.m. to 10 p.m. And all these sessions are actually recorded. Okay, all these sessions are actually recorded. You are going to get that video on a daily basis. We are going to share the video in the YouTube playlist URL, and you can watch the video whenever you are unable to attend the session. So that provision is also out there, and these videos you are going to have it for lifetime access. Lifetime access will be there for all these videos. And we are also going to share the sample application, artifacts, and everything through the Google Drive. You can download it, you can set up everything in your machine, and you are also going to learn along with me each and every concepts. That is how we are going to do as well, guys. Okay, so which means that any question related to course timing, course content, and everything, please reach out to Kumar sir 8019952427. Okay. For the learners who joined today for evaluating us, please reach out to Kumar sir for further information. And one more thing, actually, we started. I mean, we already started discussing about the course content and everything. We are discussing a lot of key things. We are discussing. Even I'm saying like what is actually they'll ask in the interview and all, right? So yes, we are already into the learning. But if you don't want to miss any critical topic or real world examples, real time challenges in everything, please reach out to Kumar sir for any further information. 8019952427. And thanks for the learners who joined today for evaluating us. Thanks for giving me this opportunity to share my knowledge and experience with you people. Definitely, this entire course journey is actually going to be like this. Lot of important things we are going to discuss. Lot of informative things that we are going to discuss. It will be helpful for you to crack the interview or any discussion forum that you are speaking. You will be talking like a pro. You are going to talk like a profiled performance engineer. So in that reason only we are going to learn about performance engineering concepts, guys. Okay. So any question, guys, till now? With this, we'll complete our session.
Can we speak with
Sorry.
Can
Yes,
we speak
Chidambar.
with Kumar sir?
Right now? Yeah, you can.
Yes. Okay.
Yeah.
Okay.
So with this, we'll complete our session for today.
Thank
We'll
you.
regroup tomorrow. Thanks for joining and have a nice day. Bye-bye.
Yeah.
Thank
Thank
you.
you.
Thank you, sir. Thank you.